Hey class, here's a short quick video on all things to know about Coulomb's law that we're going to need for this next test on electrostatics. First up, basic charge questions. We're not even using the formula for these, we're just using our common sense. Now this is kind of like what we did during gravity with Newton's universal law of gravitation. Take a look at this example. Two objects have an electrical force of 110 newtons between them. What happens to the force when Q1 is tripled? Well, Q1 and Q2 are both in the top of our formula. So if they're tripled, the force gets tripled. It's a direct relationship. So we're going to take our original force, 110. If Q1 gets tripled and Q2 remains the same, that's going to increase our force by 3 times, and our new electrical force is going to be 330 newtons. Okay, so charge is easy. What if we did distance? Okay, now distance is in the bottom of our formula, and it's squared. So it's a little bit more tricky than the Q's. What if the distance between them is changed to 1/4 of the original distance? Now think of this before you start rationally. If two things have a certain charge and they get closer, is the charge going to go up or down? The force is going to go up. 1/4 the original distance. So right now we're at R, and that's 110. We want to know what is the force at 1/4 R. Well, first up, we have to get that 1/4 to the numerator. So we have to flip it. And when we flip it, we take the reciprocal. So R, 1/4 R turns into 4R. But we have to remember to square that. So 4R squared, we're going to lose that R, turns into 16. So the force is going to be 16 times what it was originally. And what does that come out to? $1,760 newtons. So just remember to use your inverse square law practices when this comes into play. If it's in the denominator, you have to flip it, take the reciprocal to get to the numerator, and then don't forget to square that value. What if R is doubled and Q2 is quadrupled? Well, now we got two things involved. Let's start off with 110. And the easy one to do is the Q. So if Q is quadrupled, that's times 4. Our force is going to multiply itself by 4. Which means we now have a force of 440. But it also says R is doubled, meaning now you're 2 times further away than you were originally. So look at it again this way. 440 at R is going to be how much at 2R? Okay, we flip this to the numerator, but instead of 2, it now becomes 1/2. 1/2 squared. When you multiply that 1/2 squared, you get 1/4. So now that force is going to be 1/4 of the original. So 1/4 times 440. And guess what? We're right back to that same force. 110 newtons. So that's basic electrical force problems. Let's move into actually using Coulomb's law. What is the electrical force between a 15 microcoulomb charge and a 7 microcoulomb charge that are 22 centimeters apart. Before we start anything, we're going to write a few things down. First up, the formula. F of EL equals K Q1 Q2 over R squared. What's K? That's our constant of proportionality, which is 9.0 times 10 to the 9th. And again, it has units, but we're not going to worry about that because we know all of our unwanted units are going to cancel out. Now, to use this formula, we have to have meters and coulombs. We don't have either one of those on this problem. So let's get that first. 15 microcoulombs is 1/1,000,000th of a coulomb. So we divide 15 by 1,000,000, we get 0.0000015. 7 microcoulombs be 0.0000007 coulombs. 22 centimeters, a centimeter is 1/100th of a coulomb. So we're going to move that decimal place 2 places to get 0.22 meters. Now we can solve this problem properly. F of EL equals K, even though it's written in the middle, goes on top. 9.0 times 10 to the 9th multiplied by our first charge, 0.000015, multiplied by our next charge, running out of space here, all divided by 0.22 squared. All right, let's simplify that. F of EL. Now be sure when you're putting these in your calculator that you put parentheses around everything. 9.0 times 10 to the 9th, 0.1234515, 0.123457. We get 0.945. When we multiply these three values together. Now multiply the radius squared. We get 0.0484. And now we're just going to divide those two numbers. 0.945 divided by 0.0484. And we get 19, that's not 19, 19.52479. It's not necessary to keep all those. We're going to keep one decimal place. If you round to that 5, then 2 doesn't do anything. So 19.5. We were looking for the electrical force, so that's newtons. All right, that's one problem. We can have what is the force. We could also have how far apart. So we're solving for R on this actual problem. Let's move it over just a little bit. Now I'm going to do my work over here so you can see it better. So first up, we want to write our equation. It tells us the electrical force is 710 newtons. That equals the constant of proportionality, 9.0 times 10 to the 9th, times Q1. Now these are both in coulombs, so we can keep that number. 13 times 6 divided by R squared. Okay, now let's simplify this. 710, that's easy to simplify. 9.0 times 10 to the 9th times 13 times 6. 7.02 times 10 to the 11th. And then that's still over R squared. We got to get rid of this denominator, so multiply both sides by R squared. Cancels over here. We end up with 710 R squared equals 7.02 times 10 to the 11th. Now we're going to divide both sides by 710. Gives us a really big number. Let me double check that I had this written down right. 9887 4.4. Right. But that's still not R, that's R squared. So to finish it off, we have to do the square root of both sides. Save a little space here. R squared. We got to do square root, cancels that. Take the square root of that big number. Still a pretty big number, but more manageable. We end up with R equals 31,444. 0.1 meters. Okay, so that's part 2. If you're solving for R, line everything up, do your algebra, and then don't forget at the end, you have to take the square root of whatever your final simplified answer is going to be. Last type of problem you could have would be a charge problem. So what's the value of this charge? Q1 is 20 coulombs, R is 18 meters, and the electrical force between the two charges is 295 newtons. Based on this, what's the value of Q2? So just plug everything in. 295 equals 9.0 times 10 to the 9th times 20 times what we're solving for, Q2. All divided by 18 squared. All right, do some simplifying. 295 equals 9.0 times 10 to the 9th times 20. That gives us 1.8 times 10 to the 11th And then don't forget we have that still times Q2. 18 squared, 324. Now we're trying to get Q by itself, so we got to get rid of this denominator. Multiply both sides by 324. Cancel, cancel, times, we end up with 95,580 equals, save some space here, 1.8 times 10 to the 11th Q2. Last step, divide off this 1.8 times 10 to the 11th. Cancel, cancel. Got to do it to both sides. And for Q2, we end up with a very small charge of 0. A lot of zeros, 531. Now let's put that in scientific notation. So 5.31 times 10. 1, 2, 3, 4, 5, 6, 7. 5.31 times 10 to the negative 7th, and then coulombs because we solved for Q. Please let me know if you have any questions about this, because when we take the test next week, you'll have to solve both basic force questions and questions using Coulomb's law.